So today, if we're doing rational equations, there's a couple things that we need to talk about. First, we've got to figure out how to find the least common denominator. Okay, so let's say I have, 3 over x plus 3 plus 2 over x minus 1. Just like if we were adding regular fractions together, because these two denominators have nothing in common, yes. Okay. Because these two denominators don't have anything in common, the least common denominator would be x plus 3 times x minus 1. Just like you did in today's warm-up, you just multiplied the two numbers together when they didn't have anything in common, right? Okay, same thing here. Now here's the next thing I need to talk about. As we're doing a least common denominator, we also can find what we call restrictions. Okay? So we're going to need to state restrictions today. Restrictions are anything that makes the denominator 0. Okay? The other word that this book sometimes uses is extraneous. All right, so if you get an answer that can't work, it's considered extraneous. Restrictions for this is what makes the denominator 0. So in this case, x cannot equal what two numbers? And? Right. Okay, so if when we solve it we get one of those answers, those are extraneous solutions that really do not work. All right? Any questions so far? Okay, so the easiest thing to do is start off with an example, and you guys talk me through this. Okay? We're going to start off really easy. So example number 1, I want you to solve, and maybe we have something like let's go x minus 2 over 3 plus x plus 5 over 3 equals 1 over 3. Okay, so I started with this one because it's already got a what? A common denominator, exactly. Since all the denominators are the same, we can just add the numerators together. Because what we would really do, technically, would be clear the fraction, right? We would multiply every one of these by 3 to get rid of the fraction, and all of those 3's would cancel. We would be left with x minus 2 plus x plus 5 equals 1. Now we would go ahead and solve the basic equation we always have. X plus x is 2x. Negative 2 plus 5 is 3 equals 1. Subtracting 3 to the other side, we get x squared equals negative 2. Dividing both sides by 2, x equals negative 1. Now who can tell me why I didn't ask about restrictions this time? Yeah, there's no x in the denominator, right? So there isn't any restrictions because there is no variable in the denominator. So this is what we're doing today. Any quick questions before I keep going? All right. So no graphing today. How's that? Okay. Example number 2. So we're going to get a little bit tougher. All right. And I want to go with x plus 10 over x. Let's go equals 7. All right. So first of all, what's my common denominator? It's x, right? Okay, so if I state my restrictions over here on the left, what can x not equal when I'm all done? What would make the denominator 0? I can put a 1 in here and that still works, doesn't it? 0, yes. If I have just an x in the bottom, it can't equal 0. All right, So now, the common denominator is x. And remember when we clear the fraction, we multiply by the common denominator, right? So we're going to multiply everything by x. In the first one, x times x, x squared. Here, my x's cancel, so I have plus 10 equals x times 7, 7x. All right, now we got to figure out how to solve this. This is a quadratic. If it's a quadratic, we set it equal to what? 0. So I'm going to subtract 7x over. So I have x squared minus 7x plus 10 equals 0. Now, how do you want to solve it? All right. If I factor this, I put 10 on top, negative 7 on the bottom. What are my... Yes, negative 5 and negative 2. So that's x minus 5 times x minus 2 equals 0. That means x equals what? 5 and 2. Very good. Are either of those extraneous? Nope. So we are good to go. Okay? Just making, are we doing okay? All right. So let's make it a little harder. Okay. Example number 3. Let's go with how about 2 minus 3 over x plus 4 equals 12 over x plus 4. All right, so what's my common denominator this time? Okay, so technically I'm going to clear the fraction with that. What would be my restriction? What can x not equal when I'm all done? Negative 4 would make that 0, right? So I'm going to multiply by my common denominator to every single thing. In the first one, I'm going to have 2 times my x plus 4, and I'm going to write it that way. In the second one, what happens to the x plus 4s? They cancel, so we just have minus 3. Equals, how about over here, what happens to my x plus 4s? They cancel, so I have 12. So now I can go ahead and distribute, right? 2 times x is 2x. 2 times 4 is 8. Minus 3 equals 12. So combining like terms, I have 2x plus 5 equals 12. Now what? Yeah, subtract the 5 from both sides. So I have 2x equals 7. So x equals 7 over 2. Is that extraneous? Good. All right. So are we doing okay? I can make it a little bit harder. All right. Sounds good to me, too. I really want to. Example number 4. Losing my voice. That's not good. All right. Let's say we have 3x over x plus 5 plus 1 over x minus 2 equals 7 over x squared plus 3x minus 10. Okay. Nope, I don't want to do any boxes. So here's what we want to start with. Because you need to know what the common denominator is, we're going to factor that thing underneath 7, right? So we're going to start by factoring this, because those are both basic factors. We're going to factor this one. So if I put negative 10 on top, 3 on the bottom, what do I get? 5 and negative 2. All right. So that means under here, my factors are x plus 5 and x minus 2. Right? Which I also have over here. So technically, my common denominator is both of those factors together, right? Everybody agree? Okay. So let's talk about restrictions before we keep going. X cannot equal what two numbers then? Good. Negative 5 and positive 2. You guys are awesome. So now we want to clear the fraction. So instead of writing all that up there, here's how I'm going to say it to you, and I think you guys will like this better. In this first one, I have 3x times whatever factor this is missing from the common denominator. What's this missing? The x minus 2, right? The x plus 5 is there, which means that would have canceled. It's not, it doesn't have the x minus 2. Plus 1. What is this one missing? The x plus 5 equals 7 times what's this one missing? So it's just 7. Do you guys like me saying it that way better? Okay, I thought you would. All right, so now we just got to solve it. So let's start by doing the distributive property. So 3x times x is 3x squared. 3x times negative 2, negative 6x. Rid of this one. 1 times x is 1x. And 1 times 5 is 5 equals 7. All right. Combining like terms, I have 3x squared. Negative 6x and x is negative 5x. And then, are you guys okay if I subtract 7 over at the same time? So we have negative 2 equals 0. Why am I setting it equal to 0? Yeah, because it's a quadratic. So we either have to factor it or we have to do the quadratic formula, right? So let's see if it factors. Is that what you guys prefer? All right. So last number times the first is negative 6. Middle number is negative 5. Negative 6 and 1. Which means I also have to do what? Got to put it in the box. My first spot is 3x squared because the leading term is not 1. Last term is negative 2. My diagonal is negative 6x and 1x. Out of the first line, I can take out a 3 and an x. How about out of the bottom line? 1. Good. How about up and down? And how about out up and down here? Negative 2. So my factors are 3x plus 1 times by x minus 2. So now x equals what? What's the first one give me? Negative 1 over 3. I agree. How about the next one? 2. Are either of these extraneous? The 2 is. So I want you to cross it off. All right. So before I do another example, you guys talk to me. Questions at all? What are you thinking? This isn't bad, right? It's just like clearing the fraction. It's just a little more intense clearing the fraction, right? Okay, so shall we try another one? Okay. Here we go. Example, what am I on? 5? Okay, thank you. Example 5. So let's go with this. I have x plus 3 over x minus 2 over x plus 3 equals 6 over x squared plus 3x. So again, the first thing I want you to do is factor anywhere you can. So where can I factor here? Very good. You can undistribute an x out of this one. And that would leave us with x plus 3, right? So our common denominator is actually that, correct? Okay. So in this first one, I have x plus 3 on top, right? What factor is this one missing? The x plus 3. So I have to multiply it by x plus 3. Next one is minus 2. What's this one missing? Good. Equals 6. Because both of the factors are underneath 6. That's the hardest step of this, is understanding what you have to multiply each thing by. If we got that, then we are good, right? Oh, I forgot. What are our restrictions? My bad. Good. X cannot equal 0, negative 3. Thank you. I forgot. All right. So now in the first two, I'm multiplying two binomials together. So what do I have to do? Got to do myself a little tiny box over here, right? X plus 3 times x plus 3. X squared, 3x, 3x, and 9. So we have x squared plus 6x plus 9. Negative 2 times x is negative 2x equals 6. Now we want to combine like terms. So x squared, 6x and negative 2x is 4x. Oops, that's 4x. And then are you guys okay if I subtract 6? Plus 3 equals 0. So do we want to try and factor this? Okay, throwing it in our x, 3 on top, 4 on the bottom. 3 and 1, all right. And we can write it as factors. X plus 3, x plus 1 equals 0. That means my solutions are x equals what and what? Good. My solutions are x equals negative 3 and negative 1, but Braden's right. Negative 3 is extraneous. Okay. Still pretty good on these? All right, so here's what I want to say next. Example number 6. You're going to get to a couple that give you a graph. So let's say I give you this graph. You're not graphing. They're giving you a graph to look at. All right. And they tell you that you get solutions of x equals negative 2 and x equals 3. The only question I have for you is, out of those two solutions they got, which one of those is extraneous? So, remember what Brianna said to begin with, right? X is the solutions where it crosses the x-axis, right? Well, we only have one of those where it crosses the x-axis. Negative 2. So what do you think that means for x equals 3? Yes, x equals 3 is the extraneous. All right, so you have a couple problems where they just show you a picture. They give you two answers above it. They want to know which is extraneous. So you look at the picture, you say, okay, well, I know my solution's at negative 2. It does not cross at 3, so that's extraneous. All right? Okay. Yeah, this is my solution, is where it crosses the x-axis. Right? And I think I've made you guys repeat that probably a million times over the last few years. Right? Okay. So I think this can be my last example today. Example number 7. How about 3x over x plus 2 plus 2 over x plus 1 equals 5 over x squared plus x minus 2. Okay. Step 1, you have to factor, right? All right. So this one over here, I'm going to draw my little x, negative 2 on top, 1 on the bottom. What are my sides? 2 and negative 1. So my factors are x plus 2 and x minus 1. Do we all agree? Oh, this is supposed to be a minus 1 right there. I'm sorry. That's a minus 1. Can you guys fix that in there? There you go. Okay. So now let's talk about where can x not exist. Negative 2 and 1. Very good. Negative 2 and 1. All right. So here we go. In the first one, I have 3x times what factor? The x minus 1, right? You fixed that, Brayden? Okay. X minus 1, I agree. Plus 2, what factor is the second term missing? Good. X plus 2 equals, what's the 5 missing? 9. So we're just 5, right? Good. Distribute 3x times x is 3x squared. 3x times negative 1 is negative 3x. We go to the next one. 2 times x is 2x. And 2 times 2 is 4 equals 5. 3x squared. Combining like terms, I get negative x. You guys okay if I subtract my 5 to this side? So negative 1 equals 0. Okay. Let's see if I can factor it. If I put negative 3 on top, negative 1 on the bottom, are there factors with negative 3 that will give us negative 1? Nope. So can I factor this? Nope. Guess what we have to do? Quadratic formula. A equals 3. equals -1. And C equals -1. So we have negative b, so +1, plus and minus the square root b squared minus 4 times a times c all over 2a. Underneath that square root, what do we get? 13, good. So we have 1 plus and minus the square root of 13 over 6. Does the square root of 13 simplify? No. Do either of those match our restrictions? No. So those are our two solutions. Okay. I want to do one that didn't factor before we... All right, if you have no other questions, we're doing 2 to 30 even. Not that many. You'll be fine. Some are really easy. Thank you.